So let's look at some examples. Find the volume of a solid of revolution formed by revolving the region bounded by y equal x minus x cubed and the x-axis from 0 to 1. Rotate around the y-axis. So you can graph it in your calculator. I've sketched it here so we can talk about it. So the shape's going to look like this. And the radius, remember if you looked at the instructional video, is going to just be the distance to your little slice. So the radius will be x. Your height is going to be the function. And d of x will be your thickness. So you're just going to write 2 pi. And remember, we're going to use x bounds, 0, 1. We're going to put our radius times our height times our thickness. And if you put that in Math 9, you'll get 4 pi over 15. So again, when I put it in the calculator, I just do this, then multiply it by 2 in case the answer has pi in it. So look at another example. So we're going to do y equal x cubed, x equals 0, y equal 8, and we're going to revolve around the x-axis. So if you put it in your calculator, you get a little shape like this. We're going around the x-axis. So remember, we have a parallel slice. So the radius is going to be the distance, y, and the height will be the function, and then dy will be your thickness. Now remember in the shell method, when you're going around the x-axis, you're using y bounds and x equal equations. So you have to convert that equation, y equal x cubed, you have to convert it to the cube root of y. You're going to do 2 pi. You're going from 0 to 8, your y bounds. Your radius is y, cube root of y, dy. So this is your radius, your height, and your thickness. And you end up getting 768 pi over 7. Alright, so if we look at a third example, we have y equal x squared, y equal 4x minus x squared, around the y-axis. We're going to do the shell method. So remember, we're using x values bounds, y equal equations, top to bottom. So if you put it in your calculator and find your intersections, you're going from 0 to 2 on the x-axis. So you do 2 pi, x is always your radius, and then you're going top to bottom. So this is going to be your negative parabola, 4x minus x squared minus my positive parabola, which is my bottom, dx, and you get 16 pi over 3. Now, let's look at the next one. We're going to go y equal the square root of x plus 2, y equal x, and y equals 0. We're using the shell method, and we're going around the x-axis. So if you put it in your calculator, you get a sketch somewhat like this. And y equals 0, of course, is your x-axis. Y equal x in here. So shell method, if we're doing around the x-axis, we use y values as bounds, x equal equation, right to left. So you've got to convert this to an x equal equation. Then you're going to do 2 pi. You're going to use y bounds. So you're going from 0 to 2. Y is your radius. And you're going right to left. So your furthest right is just your y equal x. So you got y minus, and then what you have here. And if you put that in your calculator, you get 16 pi over thirds also. So let's look at an example where you're going to go around a line other than an axis. So we've got y equal x cubed plus x plus 1, y equal 1, x equal 1, and we're going around a vertical line, x equal 2. Now, this is where the shell method is really helpful, because if you had to convert this to a x equal equation to do the disk method, it would be difficult. So, but the shell method, we can use x bounds, y equal equations, and go top to bottom. So if you look here, if you sketch the graph, you're going around the x equal 2 line, and you're going from 0, 1 to 1, 3. 1, 1. Those are your vertices. So we're using x bound, so we're going from 0 to 1. Now because we're going around a line that is to the right of the function, remember you subtract. But in the shell method, you just do it at the radius. So instead of having x as the radius, you say 2 minus x. And then you're going top to bottom, so your top curve is your x cubed plus x plus 1, and then minus 1, which is your vertical line right there, dx. And then when you put it in your calculator, you get 29 pi 15. Let's look at one, y equal the cube root of x, and we're going to rotate around y equal negative 1. So we got, these are our functions. Here's our sketch. Now in the shell method, this is a horizontal line, so we have to use y bounds, x equal equations, right to left. So we're going to come down here and we're going y bound, so we're going 0 to 1. Now your line is below your function, so you add it, and in the shell method you just add to your radius. And you're going right to left, so you're going y minus your y cubed line, and you get 23 pi over 30. So you're doing right to left on that. So I wanted to finish up with number 4 from the interactive practice. You may have looked at it and even looked at the solution and maybe didn't understand it. So on that problem was y equal x squared, y equal 2 minus x around the x-axis. We're going to do the shell method, which means we're going to use y bounds, x equal equation, right to left. So if we convert our equations to x equal equations, we get this. But the key here, if you're going right to left, look at this. This line right here does not come into play till at 1. So from 0 to 1, all you have is the parabola, which when you convert it is the square root, so you have the positive and negative. So when you go from right to left, you're going positive, negative. And then when you come up here and you go right to left, you're going from here to your negative part of your parabola. So if you look, you're going to go from 0 to 1, and you're going to do your positive minus your negative, and of course you multiplied it by your radius, plus 1 to 4, and you're going to do right to left, so your line is right of your negative parabola, so you do 2 minus y minus your negative dy, and then if you put it in your calculator, you'll get 14.4 pi.